Okay, hello, can you hear me?
Yes, sir.
Okay, well, so give me 1 minute. I will start the
Yes,
streaming
sir.
and then we'll proceed with the session. Okay, give me 1 minute. Just. Okay, very few people have joined. Is there any other session going on? Or okay, so let me start. So that how many of you have covered the week 12 content? Somebody is saying he didn't. What about others? Neha.
Sir, I was trying to cover it, but the toughness is so much.
Okay. How many lectures? Any? By the way, how you have covered? I mean, have you seen any lectures, or you just started and then give up?
So I just got started
Okay.
and I got confused in multivariate and variance and all.
Okay. No problem. We will discuss that. That I don't think that should create any problem. Okay. What about others? Yes. No. I don't think there is any harm to say yes. No. Right. There is no penalty if you are saying no. Okay. Then. No problem. So we'll start. I will start, and then maybe I will try to give you a quick.
Good evening, sir.
Good evening. Good evening. So I will try to give you the quick summary. Okay, and maybe that will help you to understand the content of week 12. Uh, okay, so let me share my screen.
Excuse me, sir.
Yes, tell me.
Sir, at last, one topic, can you please explain about the Jacobid after the transformation we studied in week 11?
Okay, so what is the doubt there?
Sir, I didn't understand its theory part, like the formula we have to complete that part. After the transformation, the Jacobid and matrix we form na partial something.
Mm-hmm.
This part is not clear. Can you please explain this at last of today's class?
Okay, at the end of the session, right? So
Yes,
yeah,
yes, sir.
no problem. Yeah, we'll discuss. So that's Jacobian anyway. So that concept is just transformation of random variable, right? So what is the meaning of transformation of random variable? So if you have information about one random variable, I want to know the, let's say if I have information about the distribution of random variable x, I'm interested to know the distribution of y, right? Y is the, let's say, function of x, it's x square. So for example, x, I'm saying x is the length of a square, then what will be the y? Y is nothing but area of the square, right? So in real life, you'll see, it's not. I mean, you have information about one random variable. You might be interested in uh, to find the distribution of about some other random variable. So let's say speed example, right? So what is the speed? How will you calculate the speed? How can you calculate the speed?
Sir, speed.
Yeah, speed.
Sir, speed
What
is
is the
equal to
formula for speed?
distance upon time.
Distance upon time, right? So sometimes suppose if you have information about distance and time, right, and you are interested in the speed,
Sir,
right?
are you sharing your screen
No, I
or you
didn't
are
say.
just
No, I'm
okay?
just saying. Yeah. Okay. So I'm just trying to explain the same example which we took in the last class, right? So there are other things, right? Also, so uh, for example, power, voltage, and all, right? Basically, you are interested in one random variable, and you want information about some other random variable, right? Okay. So let me 1 second. Let me think. Go to. Give me 1 second. I will try to give you a rough, quick idea about that, and then then just a minute. Huh? I'm just opening that PDF so that I can explain. Okay, let me share my screen. Will share my screen and then 1 second. Now, can you see my screen? This white page. Yeah.
Yes, sir.
Somewhere we discussed about transformation of random variables. I think it should be at the end. Yes. So this example, right? So this is the transformation of random variable, right? So as I said, right? So if you have information about one random variable, let's say you have information about x, which is length of a square, but you are interested to calculate the, let's say you want to calculate the distribution of y, which is x square, which is a function of x, that is area. Similarly, if you want to calculate for speed, which is distance upon time. So for univariate, right, in case of univariate, if you know the distribution of x, so you are interested to know what is the distribution of y is equal to g of x, correct? Similarly, for if you have bivariate, right, two random variable case, then suppose you know the distribution of joint density of x and y, then you want to know the what is the distribution of u and v, where u is some function of x and y, and v is another function of x and y. Okay, and what was the formula in case of this single variable? So this fy of y is same as fx of x into this absolute value of dx upon dy. Okay, this was the formula, and there was the case, right? In this case there was some conditions, so this function should be monotonic and differentiable for the support of x. If it's not, you have to start with the general form, right? So and another thing is in case of two random variables, so if you can relate with this formula. So this joint density of u and v will be joint density of x and y into determinant of Jacobian. And what is this Jacobian? Jacobian, J is nothing but determinant of this del xy divided by del uv. So you can see you are interested in y. I mean, just to keep in your mind, it should be in denominator. I think discuss in more detail for maybe solve the session. Uh, Opening 1 second. So I think I discussed in more during the solve with us. Yeah. So in solve with us, I think I should discuss more, and I solved some problems as well, if I'm not wrong. So maybe you can yeah, correct. So you can I would suggest you to rewatch this solve with the session again at the end, so you can see this distance traveled and all. Let's say salary after tax. I mean, suppose x is information, x is I mean, information about x is already given to you. That's a salary. Then you want to know the what is the salary after tax. So let's say 0.8 times of x, which is again some function of x only. Similarly for like two case, right? So I mean, two random variable. Suppose you have information about person height and weight are recorded, but the doctor is interested in the BMI, right? Body mass index. This would be, let's say, u is y divided by x square. This is again function of x and y, and you can keep y as a sorry, v as a x, and then we what we are doing, we are transforming this x and y into u and v. I discussed the general approach. You can start with the CDF and slowly you can find out the PDF. And there is one concept: if the function is this y is equal to gx is monotonic function for the support of x, then you can apply this function, this theorem or this formula directly. For example, you can say this: if x follows exponential lambda, then this find the PDF of x y is equal to x square. So in this case, if you see y is equal to x square, if you draw, so this will be this ball, right? So but this ball is not monotonic, but for this support, right, for support of the x, I mean range of the x, so this in case of exponential, this x is greater or equal to 0, correct? So for this support, this is monotonic, correct? Now I can apply the theorem directly. We applied, we solved this question. Similarly, we solve for bivariate case, right? So in case of bivariate, u is equal to one function of x and y, v is equal to some another function of x and y, right? And this, and you can relate with this formula, right? So in case of single variable, so this fy is the transformed version, this uv is the transformed version. This is the original, this is the original into, you can see absolute value of dx dy. Since there are two variables, so we are dealing with the this their determinant, which is called this Jacobian, right? So this would be del x del u del x del v, del y del u del y del v. I took one example as well. So suppose u is x plus y, then v is equal to x, then how would you proceed, right? So everything we have to convert in terms of x and sorry, u and v. And this was the, I mean, example I took this joint density, and then we started, right? So u was this square root of x square plus y square, v was x. Then my question was, what is the joint density of u and v? Then we solved this other steps, and finally we get into the joint density of u and v. Okay, is the anyway, is the rough idea clear?
Yes, sir.
Okay. Okay, so let me deal with, I mean, start for this week 12. Okay, is the idea clear? Who asked this question is now some
Yes, sir.
high level idea. Okay, yeah,
I will watch the session
yeah,
again
you can
for
watch anyway.
yes.
So if time allows, we will discuss at the end of the session. That's not a problem for me. Okay, so let me start with the week 12 content, that is bivariate. I will start with the bivariate scenario. So before that, actually, so see, I will give you some one, two to three different scenarios for bivariate normal distribution. Okay, so first of all, if you have, suppose I'm saying x follows normal mu comma sigma, then what is the density? Usually we write 1 upon square root of 2
Under root
pi
2
sigma,
pi sigma square
right?
E
Yeah,
का
so,
power
x to
minus
the power x minus mu
right?
का mu
Yeah,
square.
x minus mu divided by sigma whole square. That is
Yes, sir.
something correct. Now, if x is, let's say I'm saying this is the standard normal. I mean, suppose z is what, x minus mu divided by sigma, then this will be standard normal. And what will be the fz of z? I mean, mean is 0 and variance is 1. So this would be 1 upon square root of 2 pi into e raised power minus 1 by 2 z square. Am I right?
yes, sir.
Yeah. Okay. Now, so let's start. Suppose I'm saying let Z1 is one standard normal variable. Z2 is another standard normal variable. There is some background noise. Yeah, if you have doubt, you can unmute. Just go to. Okay, suppose I have some.
Excuse me, sir.
Yeah, please.
The fz of z is equal to 1 by under root 2 pi e to the power minus 1 by 2 z square. It's okay, sir, but why did you wrote fz of z? It should be f x of x only, no?
How? Because I'm interested in this Z, right?
Yes, you're interested in that z, so we
Hmm.
are just replacing the whole x minus mu by sigma by z.
No, no, it's not like that. See, what we are doing. So this Z is standard normal. How will you compute? Okay, forget about this. How will you compute the standard normal? How will you convert a random variable into standard normal? We are subtracting the mean and dividing by the standard deviation of x.
Yes, sir.
Right? What is happening here? This mu is what? This is mean. This is expected value of x, and this sigma is standard deviation of x. Right? Now
Yeah.
this 0 is expected value of z, and
And
this
one
1
is
is uh,
variance, sir.
variance of z. Right? That's all. Okay. So if you see, okay, so this is happening basically. This is something z minus 0 divided by 1 whole square. I skipped one step actually.
So that sigma in the numerator, what happened to that? 1 by root 2 pi sigma is there, no? So fz
Yeah.
of
So in
that,
this case, sigma will be 1, right?
oh, okay, yeah, because it's 0 comma 1. Okay, okay,
Correct.
sir.
Correct. Okay. Yeah. So suppose I have some d standard normal variable. So if I want to write in, let's say, okay, before that, what will be this joint density of this all? I mean, product of this all d standard normal variates. If I want to write to like or find a kind of, I'm interested to compute the likelihood of these steps. So can I write this as a basically fz1 z2 so on zd, small z1 small z2, let's say small zd, since all are iad, right, all are in the same normal distribution and all, so I can write fz1 z1 into fz2 z2 and so on zn sorry zd, right? Yes or no? What is happening here? So this all are standard normal variables. So what else can I write? Can I write 1 upon square root of 2 pi exponential of minus 1 by 2 zi square, right? Product of I is equal to 1 to d, yes or no?
Yes, sir.
Right? And now what is this case actually? Can I write this as a 1 upon 2 pi raised power d by 2, correct? See, this square root I can write 2 pi raised power 1 by 2. This is d times, so it would be d by 2, correct? Into exponential of minus 1 by 2, and this okay, if you have something, let's say e raised power minus x1, e raised power minus x2, and okay, so if you will apply this product sign here, what it will be? I can write this as a e raised power minus summation of I is equal to 1 to d zi square, yes or no? This is, see what is happening here, e raised power minus z1 square divided by 2, e raised power minus z2 square by 2, and so on, e raised power minus zd square divided by 2, correct? Then power will be added, yes or no?
Yes, sir.
See, if this is the case, what else can I write? 1 upon 2 pi raised power d by 2, and this is something can I write exponential of minus 1 by 2 norm z square, yes or no? Would you agree with me? See, this summation zi square, if you see from the algebra steps, so if I have z transpose z, I can write this as a summation zi square, which is nothing but norm z square,
Yes, sir.
correct? See, this is just to give you idea. See here what I'm doing. So I'm interested in, so suppose I have vector of this all zi's, right, which is d cross 1 vector. So what is the density of this fz? Okay, so is the rough idea clear? Some steps are clear.
Sir, the norm z square is still not clear, sir.
See, what is norm z square in from the linear algebra stuff?
I mean, sir, how did you got a summation of I equal to 1 to d zi square equal to norm z square?
See, if you have some linear algebra steps is there. Okay, suppose I am saying I have a vector, right? So let's say a1 a2, let's say a1 a2 only, and this is a1 a2. What else can you write? If you multiply this, it will be a1 square plus a2 square.
Yes.
What is this a1 square a2 square? I can write summation ai square also, and this is norm a square also. If my vector is a1 a2, that is norm square, right? Norm is what? Is square root of this a1 square plus a2 square. Correct?
Yes, got it.
This is a transpose a. That is the same thing I wrote. Okay. So okay, let me start with this part. So start, that is something for bivariate itself. So we'll see some two to three different form of bivariate. So we use this transformation of random variables, right? We saw that part, and in that case, what else we needed? If you see, we needed this part, right? So this joint density is equal to fxy into absolute value of Jacobian. Okay, before that, just be with me. I mean, it will be clear in a minute. So suppose I'm saying I'm defining x1 as a z1, okay, and x2 as a rho times of z1 plus square root of 1 minus rho square times z2, where rho is a constant which takes value minus 1 to 1. Okay, now if you see, if I want to write this x in terms of vector, I can write x1 x2 collectively. See, I'm going to start with explain everything in terms of vector notation. Okay, even see, if you want this, let's say if I need the joint density of this x1 and x2, right? Then what else I need? Fx x1 x2 x1 comma x2. I need fz1 z2 z1 comma z2 into absolute value of Jacobian. Yes or no? And what will be this j? J will be del x1 x2 divided by del z1 z2, correct? And then this would be same as determinant of del x1 del z1 del x1 del z2 del x2 del z1 del x2 del z2. Yes or no? From here it is clear. I want x1 x2. I have information about z1 z2 and then Jacobian. Clear? Yes? No? This form is okay?
Yes, sir.
Okay.
Yes.
So finally, see, here there are two approaches. Either you can okay, what will be the differentiation for del x1 with respect to z1?
One.
One.
1. Okay. And what about the
Excuse me, sir.
hmm?
Here we want with respect to x1 and x2 only, right?
Correct.
So denominator it should be dou x1 or z1, sir. In Jacobian.
Correct. Very good. Yeah, thanks. Sorry for this confusion. So this would be, I have information about z1 z2 and it would be x1 x2, correct? Yeah. So this will be in reverse order everything. So this will be in dou z1 del x1 del z1 del x2 del z2 del x1 del z2 del x2. Yeah, thanks. So this is one way, right? So what you can do, you can compute this joint density of z1 z2. I will tell you, right? And then you have to everything you have to convert in terms of x1 and x2. So you can substitute z1 as x1, and in this form you have to find the value of z2, right? So this will be z2 equal to what? x2. I mean you have to replace everything, right, in terms of x1 x2. This would be x2 minus rho z1 divided by square root of 1 minus rho square. Are you getting my point?
Yes, sir.
Okay, so basically this would be, okay, from here this z1 will be x1, right? I can replace z1 with respect to x, I mean with x1, and from here what will be the z2 will be x2 minus rho z1. So instead of z1 I have to replace with x1 divided by square root of 1 minus rho square. Are you getting?
Sir, where the expression for x2 is equal to rho z1 plus this 1 minus rho square under root z2 comes.
That is something we have let. This is one of the transformation. It will help you to understand the later how this bivariate formula came actually. Okay, so one second, let me create some space from here. One second. See, everything we have to convert in terms of make it in terms of x1 and x2. So from here I can write z1 as a x1, and from here what else can I write? I can write, so this okay, first of all this would be square root of 1 minus rho square z2 is equal to, I can write x2 minus rho z1, and z1 is x1 only, correct? So from here z2 will be what? x2 minus rho x1 divided by square root of 1 minus rho square. Yes or no?
Yes, sir.
Yes, sir.
So this is z1 is equal to x1. Now just let's try to compute this Jacobian form. So what will be this del z1 del x1,
1,
del z1 del x2,
0,
del z2 del x1,
minus 3.
del z2 del x1.
minus rho.
Minus
So
rho
minus
upon
rho by under root 1 upon 1 minus rho square.
Okay, minus rho
Upon 1 under root 1 minus rho square.
correct. So minus rho divided by square root of 1 minus rho square. And what about del z2 over del x2?
the
1
1
upon
upon
under root 1 minus rho square.
Correct. Now what is this? What is the determinant of this part?
1 upon under root 1 minus rho square.
Okay, so far so good. Now so this is Jacobian. Now what is this? Finally we have to compute f x1 x2 x1 comma x2 and f z1 z2 z1 comma z2 into absolute value of this Jacobian. Now what is this z1 z2? This is standard normal variates.
Yes,
Okay,
sir.
so z, what will be the, and these two are IID. These two are IID. I can write f z1 of z1 into f z2 of z2. This is small z2, right? This is the capital z2 and Jacobian. And this, what will the PDF of this? It will be 1 upon square root of 2 pi e raised power minus 1 by 2 z1 square,
Yes, sir.
and 1 upon square root of 2 pi e raised power minus 1 by 2 z2 square. And what is this Jacobian? This would be 1 upon square root of 1 minus rho square. Correct?
Yes, sir.
And what is this Z1 square? Z1 square I can write as a e raised power minus 1 by 2. It would be x1 square, because Z1 is equal to x1. Correct? And this would be 1 upon square root of 2 pi e raised power minus half. What is this Z2 square? Z2 is what? This whole quantity square, right? So that means x2 minus rho x1 divided by I think, yeah, square root of 1 minus rho square, correct? Whole square?
Yes, sir.
Is this whole
And the
square?
Jacobian.
Yeah, correct? Into square root of 1 minus rho square. So far so good?
Yes, sir.
Yes, sir.
Now what I'm trying to say here, you have to focus a little bit more. So 1 upon square root of 2 pi e raised power minus 1 by 2 x1 square into, what if I'm taking 1 upon square root of 2 pi square root of 1 minus rho square into e raised power minus 1 by 2, or else can I write this as a 1 upon 2 sigma square. So can I write this x2 minus rho x1 square divided by 2 into 1 minus rho square. because this square root will be this square root of 1 minus rho square whole square will be 1 minus rho square only. Is this clear?
Yes, sir.
Sir,
Okay, so
why are we dividing by root of 1 minus rho squared? In
this one,
no, sir. Oh, okay.
this quantity, this is
Okay.
this came from Jacobian. Huh?
Okay, sir.
Okay, so one thing you have to keep in mind. So there is something we have seen. What if I'm saying f x2 given x1, right? For x2, so this would be okay. Numerator will be joint density. Denominator will be this marginal of x1.
Yes, sir.
From here, can I write f x1 x2? This joint density. This is same as f x1 of x1 into f x2 given x1. Would you agree with me? I just take this. I just took this left hand side. Are you getting my point? Is this clear?
Yes, sir.
Now, so what is this? This is nothing but standard normal, one of the PDF. Correct? See, left hand side is what? This joint density, right? So left hand side I'm writing f x1 x2, right? So if you relate with this, so this is one standard PDF, right? It's PDF of standard normal variable, correct? This is normal for x1 with mean 0 and variance 1. Yes or no?
Yes, sir.
What about this? This would be, this is nothing but normal
Condition.
for conditional, right? So x2 given, I mean for x2, and what is the mean? What is the mean of this part?
Rho x1
Rho x1, and what is variance? 1 minus
rho square.
Now you can relate, right? 1 upon square root of 2 pi sigma e raised to power minus 1 by 2 x minus mu whole square divided by sigma square, correct? Now what is this? So this is nothing but f x1 of x1 into this is f x2 given x1, x2 given x1. So this is something you can relate. So from here, what is the information I have? X1 follows normal with mean 0, 1, and x2 given x1 equal to x1 is follow normal with mean rho x1 and variance 1 minus rho square. Okay? Yes, no?
The green part is not clear, sir.
Where it is not clear?
From
where?
green. From green.
So what is this? This just relate with the, this is normal PDF or not? 1 upon square root 2 pi sigma, correct? This is variance part.
Yes,
E
sir.
into e raised to power minus 1 by 2 x minus mu whole square divided by 2 sigma square, right? So what is the variance? This is the variance. This is the mean, right?
Yes, sir.
This is the mean rho x1, and this is the variance. Is this clear?
Yes, sir.
Okay. So there is, see, this was one way to apply the concept of I mean this Jacobian, etc. So another way to look at it actually. So what is information I had actually? So from here, let's try to do in terms of vector notation. See, maybe you are getting bored, or is it okay to
It's okay.
Yes,
No,
sir, some kind of.
some kind
Sir,
of bored?
how we get fx2 upon x1, sir? That is not clear.
See, this is just an, see, okay, this is one PDF, standard normal PDF, right? Yes or no?
Yes, sir.
And this PDF is what? This is another, okay, just read it. This is another normal PDF for x2, which is with mean rho x1 and variance 1 minus rho square. So far, so good.
Yes, sir.
What I'm trying to say, if you see the conditional density, if I have f x2 given x1, then this conditional density, how I can calculate? It would be f x1 x2 joint density in the numerator divided by f x1 in the denominator.
Yes, sir.
If you multiply to this to the left hand side, so what is this? This would be what this will be. This will be f x1 x2. Okay, so this will be f x2 given x2 x2 given x1 into f x1 of x1 or not. If you multiply to this left hand side, this denominator, if you take to
Excuse me, sir.
Hmm?
Sir, this x1 and x2 is confusing. Can you please explain this box part by taking x, y?
See, I took x1 and x2 because here x1 and x2 is there. That's why I'm taking. See, okay.
Sir, is this something like we studies in joint PMF?
It's a joint
Effects?
density itself. See, okay, let me rewrite it again. A from here. Yeah. See how will you write the conditional probability in terms of events? I can write probability of A intersection B divided by probability of B, right? From here, what else can you write? So can you write this probability A intersection B same as probability of B into probability of A given B? Yes or no?
Yes, sir.
Now I have density f x1, let's say I'm saying x2 given x1, okay, or let's say y. So I'm saying suppose f y given x, okay. So this conditional density would be equal to fxy joint density in the numerator divided by f x of x, correct?
Yes.
From here, what else can I write? Can I write this f y given x y into f x of x equal to f x y x comma y? From
Yes.
here, what else can I write? Can I write f x y x comma y? Just interchange to f x of x, f y given x at y. Is this clear? Yes, no? So this fx x1 x2, just replace y x as x1 and y as x2. So this would be x1 comma x2. So this will be f x1 of x1 into f x2 given x1, correct? Now what is happening? If you see the left hand side, I have f x1 x2, right? And this is a valid PDF of standard normal PDF of one random variable which is for x1, correct? So this is f x1 of x1. Yes or no? Right? So this left hand side equal to this joint density, that means remaining is conditional density. Okay?
Yes, sir.
Okay, well, so let me start with this in terms of vector notation, which is actually, see, I can directly give you the form of bivariate, but it's good to deal with vector notations actually. Let me explain you. So this x1 and x1 equal to z1 we took, and x2 we took rho z1 plus square root of 1 minus rho z2. Okay, now if I'm writing x as a, let's say, x1 x2, then what else can I write? Can I write this as a z1, and this would be rho z1 plus square root of 1 minus rho square z2, correct?
Yes.
Now if something is here, if I'm writing z1 and z2 here, this is 2 cross 1, this is 2 cross 1, I should get here something about 2 cross 2, right? What will be the entries here?
So 1 0
1 0
rho and under root 1 minus p square.
1 minus rho square, correct? Correct? Only then you will get this form. Yes or no?
Yes, sir.
And what is this? This is, let's say, this is matrix A. Okay. So now what is the case? I got x as a times of z, correct?
Yes.
Or else I can write z as a inverse x. Okay. Now if this is A, what will be the determinant of A?
Sir, under root 1 minus p rho square.
1 under root 1 minus rho square. What will be the determinant of A inverse?
1 upon under root 1 minus rho
1 upon
square.
determinant of A. I can write 1 upon square root of 1 minus rho square also, correct? This is one way. Another way, what is A inverse if you want to calculate the inverse of a 2 cross 2 matrix? So this would be this replace, we have to, it would be 1 minus rho square, it would be 1, it would be 0, it would be minus rho, correct?
Yes,
That
yeah.
takes-
1 by
this would be
that. 1 by that.
correct. Okay, so what is the A inverse here? This would be 1, 0 minus rho divided by square root of 1 minus rho square and 1 upon square root of 1 minus rho square.
Yes, sir.
This is something, can you, are you able to see this entry, which I think we found out somewhere? This was something we have seen.
It is Jacobian,
right? So actually what I'm trying to say, you can, if you see, you can proceed with this approach as well, or else you can proceed with this vector notation as well. At the end you will get the same answer. Anyway, I want to explain something. Let just be with me. What if okay, let me rewrite. So I have x1 equal to z1 and I have x2 is equal to rho z1 plus square root of 1 minus rho square z2. Just you will give me answer. What about, what will be the expectation of z x1?
0.
0. Why? Because expectation of z1 is 0, correct?
Yes, sir.
Everyone would agree with me? z1 is standard normal variable, right? So this would be 0. What about expected value of x2?
So it would be the same, sir.
Expectation of rho z1 square root of 1 minus rho square z2. So actually it will be rho times expectation of z1 plus square root of 1 minus rho square expectation of z2. So z1, expectation of z1 and expectation of z2 are 0. Again, this expectation of x2 will be 0, correct? So far so good?
Yes.
What about covariance of x1 comma x2? How will you compute the covariance between two random variables? This is expected value of x1 x2 minus expectation of x1 into expected value of x2.
Yes,
Correct?
sir.
And this part will be 0 because individual expectations are 0, correct?
Yes, sir.
And what is this expectation of x1 into x2? So what is x1 into x2? Tell me. This would be x1 into x2. This would be rho z1 square plus
Z1 into Z1 Z2 into 1 minus rho square.
correct. Now, what else I can write? Can I write expectation of rho z1 square plus square root of, or else expectation of square root of 1 minus rho square z1 z2? Correct? Basically from here I can write rho times expectation of z1 square plus square root of 1 minus rho square expectation of z1 z2. Now you will tell me what should I write next?
There is only rho expectation of Z1 square and the other term will be 0.
0, right? So first of all, this rho times expectation of z1 square, this will be 1 upon rho square. Since z1 z2 are independent, I can write expectation of z1 into expectation of z2 and this would be 0, correct? And this is rho times expectation of z1 square. Since z1 is what? This is normal 0 comma 1. Then variance of z1, that is expectation of z1 square, this is 1.
Yes, sir.
So this would be rho. So this covariance between x1 and x2 is rho here. Okay. So far so good.
Yes, sir.
Now, so basically we are creating some, like just collecting some materials to make a kind of, or we are collecting some ingredients to make to cook a food or something like that. So just be with me. We have to understand this all stuff concept. So what about variance of x1? This would be variance of,
Z1
that is
1.
1. What about variance of x2? This is variance of rho z1 plus square root of 1 minus rho square z2, correct?
Yes, sir.
So from here, how will you compute the variance? Variance, what is the formula for variance? Variance of any random variable x is expected value of x square minus expected value of x
Square.
whole square. So from here it would be expected value of rho z1 plus square root of 1 minus rho square z2 whole square minus expected value of
Excuse me, sir.
yes.
Sir, we can apply that formula variance of row z1 because z1 and z2 are independent, so we can apply row square variance
Yeah,
of z1.
that is also one approach. Yeah, that is also we can do. Yeah, correct. So we can apply it will be rho square variance of z1 and yeah, correct. Let's go like this. Yeah, thanks. Even we can go with this the one which I was doing. Yeah, so z1 and z2 are independent. So from here I can write if x and y are independent, then variance of x plus y. I know it would be variance of x plus variance of y. Correct. So this would be variance of rho z1 plus variance of square root of 1 minus rho square z2. We know this if x and y, this would be independent. We know variance of any constant time of x, it would be a square variance of x, correct? So this would be rho square variance of z1 plus square root of 1 minus rho square whole square into variance of z2, correct? This would be rho square into 1 plus 1 minus rho square, variance of z2 is 1. So this would be rho square plus 1 minus rho square, this is 1. So variance of x2 we got 1. So variance of x1 is 1, variance of x2 is 1, correct? So there is something called covariance matrix. So this covariance of x, covariance of this x means this vector x, which was x1, x2. How we can make this covariance matrix? So let's say, I think this is something we have seen in while discussing the PCA as well. But anyway, this suppose this is x1, this is x2, this is x1, this is x2. So what are the entries? So this is x1, this is x2. So covariance between x1 and x1, this is same as variance of x1. This is x1, this is x2, so this would be covariance of x1, x2, correct? This is x2, this is x1, this would be covariance of x1, x2, and this is x2, this is x2, so this would be variance of x2. Is it clear? This is something, this would be, what is the variance of x1? This is 1, covariance was rho 1, and this is nothing but actually we denote as a big sigma, the covariance matrix, variance covariance matrix, okay? Yes, no? Is this okay?
So the second row and first element would be covariance of x2, x1, I guess.
Yeah, actually covariance x and y is same as covariance of y and x. Because if you see this formula, if you are calculating covariance of x2, x1, this will be x2 into x1 and expectation of x2 will be before expectation of x. Okay? At the end you will get the same. Okay?
Okay, sir.
Now I have x equal to a times z. I had, right, and where a was 1 0 and rho square root of 1 minus rho square. Now tell me what else can you comment on covariance of x? I mean this sigma. This would be what? This sigma. You can cross check. I will tell you the answer. So this would be same as a into a transpose. Okay. Now tell me, if you just come, you have a, you have just multiplied with a transpose, you will get, you'll be getting end up with this quantity. Tell me what is the determinant of sigma?
1 minus rho square.
1 minus rho square. What is the sigma inverse?
Sir, one question: how did you got the
1 upon 1 minus
covariance
rho
of-
square.
How did I get what?
Sir, how did you got the covariance of x equals sigma, sir? Did you? Is it a
This is
already
covariance
formula?
of x. This is sigma. Okay. What
So-
I'm saying, if you multiply a into a transpose, you will getting end up with this sigma.
Yeah.
Okay. Just do this homework. Okay. Fine. Now, what will be the sigma inverse? So this would be a into a transpose inverse. So this would be, what else can I write? I can write a inverse transpose into a inverse, or a transpose inverse into a inverse. Correct?
Yes, sir.
Okay. Now, what about sigma inverse matrix? This would be sigma inverse. This would be 1 1 minus rho. Basically it will be 1 upon 1 minus rho 1 minus rho 1. Correct? Just let's make it star. See, just try to follow up the calculation and all. Things will be clear in a minute. And what about determinant of sigma inverse? It would be 1 upon 1 minus rho
Rho
square.
square.
Okay, so far so good. Now, okay, so now let's start. So see, we want this transformation. So fx of x. Now this x is a vector. This is same as this would be fz of this small z into Jacobian. Okay, so I had x equal to az, right? See, in case of one dimension, one like univariate, you want to transformation, you will write fy of y into fx of x divide determinant of dx dy. Correct? Am I right? If you have x equal to a times of z, so what will be this z? This z will be a inverse x. Correct? So you have information about z. You want everything in terms of x. Correct? Now this will be this. What will be this dz upon dx? If you want to do, this would be
A inverse.
A inverse. But basically it's a matrix, so it will be determinant of A inverse, right? See, everything here is in terms of vectors, right? So I'm just trying to relate everything. So what will be this J actually? Everything is in terms of vectors only, right? So basically, what is this? So this is actually this is Z1, Z2, and A inverse matrix, and this X1, X2. Correct? So it would be finally from here, if you want to differentiate with respect to X, so this J will be determinant of A inverse. Is the idea clear?
Why determinant, sir? That is not.
See, if you see in case of 2D random variable, here we discussed, right? In case of double random variable, Z1, Z2, X1, X2, this J, how we can compute this determinant of these stuffs? Okay?
Yes, sir.
Okay, now it's clear why this is Z1. So, why this is, I'm writing determinant, yeah? So, this is Fz of Z into absolute value of determinant of A inverse, okay? Now, first of all, what is this Fz of Z? Since we are dealing with bivariate, so this would be 1 upon 2 pi into exponential of minus 1 by 2 norm Z square. Can you recall this part which we did for 2D random variable, right? This part.
Sir, why did derivative of A inverse is determinant of A inverse? That point is not clear.
Why
If
this
it-
derivative?
That
See,
box.
okay, 1 second. Okay, just relate. Just think like this. What if just treat this as a single variable? If you find dz with respect to dx, suppose this is dz, dz with respect to dx, what you will get? A inverse.
A inverse is
Right. Since these are vectors and matrix, so we have to find it will be determinant of A inverse. Okay.
it is equal to A inverse. That is understood, sir. But how it is getting?
See, this is not a single variable at all. See, I'm writing in terms of vectors. So okay, tell me if okay, just tell me this part. Z1, Z2, del x1, x2. Now we are dealing in terms of vectors, right?
Yes, sir.
So what is this? This J, how will you compute? This is determinant of this part, right? That's what I wrote. That is this determinant of A inverse. That's all. Okay, just treat this as a inverse. Okay.
Okay.
Yeah. So now erase this part. So okay, is this part clear? This norm Z square part, this fz of z, we in the beginning of the session we discussed here, right? If you have d variables, d z1 standard normal variates, so it would be 1 upon 2 pi d by 2, but I have 2 only, so it would be z1 z2, it will be 2 by 2 and exponential of minus 1 by 2 norm z square. Is this clear? And what is the determinant of A inverse? We have calculated So determinant of A inverse also is, see, you get confused about this determinant of A inverse, right? So if you differentiate, right, in the Jacobian part, if you differentiate, you are getting this same thing, right? Just see this and just see this. Is this A inverse or not? Right? Is all the entries same as A inverse? 1 0 minus rho square divided by square root of 1 minus rho square 1 upon square root of 1 minus rho square, right? And now you can see here this A inverse 1 0 minus rho, correct?
Sir, the second approach is way more easier, sir. This one.
Yeah, I'm just trying to relate with vectors and all. See, I could have finished with just one approach. I'm just trying to give you the idea about behind both approaches. Anyway, so this determinant of A inverse is 1 upon square root of 1 minus rho square, right? So let's substitute there. So this determinant is 1 upon square root of 1 minus rho square. Okay? Are you getting my point? Yes, no, this is determinant of A inverse, correct?
Yes, sir.
Okay. So what I'm trying to say here, so see this 1 upon 2 pi into exponential of, see this z, how I can write? This z I can write as a norm of A inverse x whole square or not?
Yes, sir.
Now from here, another approach is 1 upon 2, I mean next step, exponential of minus 1 by 2. Can I write this as A inverse x transpose and then into A inverse x?
Yes, sir.
Right? So, well, next step is 1 upon 2 pi into exponential of minus 1 by 2. What else can I write here? It would be x transpose, A inverse transpose, A inverse x into this 1 upon square root of 1 minus rho square. Yes, no?
Yes, sir.
So actually, see, finally, if you solve this, now from here, actually what you will do, 1 upon 2 pi square root of 1 minus rho square into exponential of, I can get this 1 minus 2 and okay, this A inverse transpose, if you see this entries, A inverse transpose, what is this? This is sigma inverse, nothing but, correct? This is sigma inverse, and now I can substitute this whole value, so it would be 1 upon 1 by 2 rho square, so this will be x transpose, this is nothing but sigma inverse, and all the entries is this 1 minus rho 1 minus, I mean 1 minus rho minus rho 1, and this is x. Okay, maybe I think you are getting bored here. So actually if you solve this right further, so finally you will get end up to this same equation which we got here, this one in, let's say, equation double star. So you can try this out. I mean this will be same as equation double star. So these were two different approaches for I mean getting that conditional part. Now let's come to the final original which you wanted to see already, which is, let me start for that. So we started from x equal to a z, right? And we had fx of x equal to fz of z into, we saw this is determinant of A inverse, right? Correct? This step, where it went, yeah, this one. Okay. Now we are coming to the final form, right? Now from here, what else can I write? Fz of this z was, I have to convert everything in terms of x, right? So this would be here, from here z will be A inverse of x, correct? So this would be A inverse of x into determinant of, I mean absolute value of determinant of A inverse. Is it okay?
Yes, sir.
Okay. Now tell me one thing. See, we discussed one thing. So let sigma was what? Sigma was same as A transpose.
Yes.
Okay. I think if you are getting confused here, I think we were here, right? So till let me start from.
Sir, I am feeling lost, sir, actually.
One second, one second. I will come to that point. So let me come to this point, right? So let me come to this point. This is this part. Okay, okay, okay. See, don't worry. See, there are too many things actually. Because of that, you might get confused. Okay, tell me, is this till this point it is okay? Right? This basic stuff. We are coming to the final form. Is this okay?
Yeah, sir, that's
Right? This is okay, fine. So from here, if you see, if I will apply this form, right? So what it would be? It would be 1 upon 2 pi, right? 1 upon 2 pi exponential of minus 1 by 2. And what we wrote? This minus 1 by 2, this form, right? Or let's say I'm writing this form directly. Okay, let me write this. Norm of A inverse x whole square into absolute value of determinant of A inverse, right? Just forget about everything. Now tell me, is this okay? This transfer, I'm applying transformation of random variable, and this f z A inverse x, this is standard normal variable. I can convert like this, yes or no? Right?
Yes, sir. Instead of Z square, we have A inverse X square.
Yeah.
Norm
Okay.
of A inverse X.
Correct. So now tell me, this form, this inside the bracket form, I can write minus 1 by 2 again A inverse x transpose into A inverse x.
Yes, sir.
Well, now just tell me what else can I write? 1 upon 2 pi exponential of minus 1 by 2. This is something I can write x transpose A inverse transpose A inverse x. Yes? No? This is 1 upon 2 pi exponential of minus 1 by 2. What is this? I can write x transpose.
A inverse whole transpose.
This quantity is what? If you see this quantity we computed, this is sigma inverse, correct?
Yes, sir. Yes.
This is sigma inverse. Now, so here what else can I write? Now I will relate with the original formula. Don't worry. So just be with me. This is sigma inverse x, okay? And what about this determinant of A inverse? So this determinant of, let me rewrite it again. Okay, so from here, so suppose this determinant of A inverse is nothing but, I can write 1 upon determinant of A, correct? And which was 1 upon, I can write square root of determinant of sigma or not, because sigma is what? A transpose. Would you agree with me? Correct. Now, so from here, what else I can get? 1 upon 2 pi exponential of minus 1 upon 2 x transpose sigma inverse x into 1 upon square root of determinant of sigma. Correct. Or else finally, what else? What I will get? 1 upon 2 pi this determinant of sigma, this is square root, I mean this is square root of determinant of sigma into exponential of minus 1 by 2 x transpose sigma inverse x. So this is actually form of binomial distribution, okay? For okay, this is binomial distribution for, right? Now let me write original form, I mean the usual formula which we are writing. Okay, suppose you have standard normal variable or normal density. What will be the PDF? Usually how we are writing the PDF?
1 by root 2 pi sigma
1 upon root 2 pi sigma e raised power minus 1 by 2
x minus mu
x minus mu divided by sigma whole
whole
square.
square.
That is something we are writing, correct? Now let's try to understand this bit more. So what else can I write? Can I write 1 upon square root of 2 pi sigma square e raised power minus 1 by 2. I can write this as a x minus mu whole square divided by sigma square. Now can I write this as 1 upon square root of 2 pi square root of sigma square e raised to power minus 1 by 2 x minus mu whole square sigma square inverse? Can I write like this?
Yes, sir.
Yes.
Okay. Now what is happening here? Now are you able to relate this as a, so this is square root of 2 pi. This is for single variate. For double variate, it is 2 pi, right? Square root of 2 pi into 2 pi. This is square root of sigma square, which was variance of x. What is this sigma? Sigma is nothing but covariance matrix. So sigma is variance of x, right? Or covariance of x here, correct? Into e raised power x minus mu whole square. Now instead of whole square, since we are dealing with the vector notation, so this would be x transpose x and sigma square inverse. So this is inverse of the variance in between. So this order is just to maintain the so that we can multiply with the order of the matrix. Are you able to relate now with the formal notation?
So can you repeat once again?
Okay, let
This
me
is-
write. Okay, let me write for like, okay, one second. What else can I write here? In general, actually, what I'm trying to do. So 1 upon 2 pi raised power d by 2 if I have d random variables. Okay, first, one second. Just, okay, now let me minimize a bit. Okay, now just see. What is this? This is 2 pi, 2 pi, right? This is 2 pi because we have taken two random variables into consideration. Okay, this is square root of variance. This is square root of determinant of this covariance matrix, correct? Exponential, exponential, minus 1 by 2, minus 1 by 2. This is x minus mu whole square. Okay, so this x minus mu whole square. So if, okay, this is something I can write x minus mu transpose into x minus mu or not, if you are dealing with the vector, correct?
Yes, sir.
So this is something I have x transpose x. Just try to relate with the
Single
just
variable.
terminology. Yeah, this is inverse of the variance. This is inverse of the covariance matrix. That's all. Is this clear?
Sir, the sigma square inverse is the just the inverse of the covariance matrix, right?
Covariance matrix, correct?
Yeah.
Okay. See,
Okay.
here it's a sigma square, just a one constant because I have one random variable, right? I'm dealing with one random variable. I'm just trying to give you the idea how to relate with this formula. Okay. Yes, no? Is this clear?
Yes, sir.
Yes, this is
Okay.
very nice, sir. Thank you very much.
Yes, sir.
Now is it fine, right? So if you have d random variables, then how will you, for multidimensional, a multivariate, it would be 1 upon, tell me, I can write 1 upon 2 pi raised power d by 2. See, if you have 1, it would be 1 by 2. That's why square root of 2 pi. Now it would be square root of determinant of sigma into exponential of minus 1 by 2 x minus mu transpose sigma inverse x minus mu. Is this clear, everybody? Yes, no? Yeah.
Yes, sir.
So now, okay, let me write for one random variable. So this for univariate. This is for univariate. If
So
you see,
basically, you're trying to relate for the PDF for a single variable to the PDF of multivariable, and they are one and the same.
correct, correct. So this would be 1 minus 2 x minus mu square sigma square. Now, this is the form of univariate random variable or not? This one, this below one which I wrote. Maybe here you are getting confused because here mu is there, but here 0 is there. So this is why, because we started with the standard normal variable. Okay, if you are getting confused with this, let it be. Just try to relate with this. Now, this is square root of 2 pi sigma square, correct? This is for univariate. Now, this would be square root of 2 pi d by 2 if you have d variate. Yes or no? Square root of sigma square root of determinant of sigma, covariance matrix. The sigma square is what? Variance. Exponential, exponential, minus 1 by 2, minus 1 by 2. X minus mu whole square. Since we are dealing with vectors matrix, so this would be x minus mu transpose and x minus mu. So these all things are here. I mean notations are here and there, just to maintain the order of the matrix so that we can do multiplication. This is inverse of the variance. This is inverse of the covariance. Is this clear now? Yes, no?
Understood, sir.
Understood, right? Yeah, great. So see, this was this all step derivation we did. Maybe you get confused somewhere, then you can let me know. That's not a problem. We can discuss it later again as well. But I hope you understood this some different form and this joint equal to marginal into conditional, etc. Everything, right? So we did in some two to three different ways. Okay, I hope that is fine. Then should we proceed further?
So
Okay.
which form should we finally
This
bring it?
form is the original form actually. This form is the main form. I mean, the density. If you ask what is the PDF of a bivariate, then what you can do here you can do 2 by 2 and accordingly you can proceed. Okay.
Sir. Okay.
And if it asking, let's say, I mean, we didn't ask in any question in MLF, but if it asking what is the conditional density of this part, right? In case of bivariate, then you can tell this normal. I mean, this is marginal. This one is the conditional. So we started with this transformation of random variable concept, and we getting end up to this PDF of standard normal, and this is conditional density of x2 given x1 by using this concept. So is this overall rough idea is clear to everybody?
Yes, sir.
Yeah. So let's try to discuss. Let's try to understand some properties. Yeah, we have to discuss.
Sir, could you scroll up to the first page?
Very first page.
Yeah, very first page, sir, where you start discussing that normal distribution. Yes, sir. Yeah, sir. In this, this is the formula for normal distribution, and suppose we replace x minus mu upon sigma by z. Then in the power we get minus half z square. But where does this sigma go, sir?
See, you are getting confused. So do not go with that like that. So it's a very straightforward, simple thing, right? So this z is what? Just do not okay. If you are getting confused with this z, you are replacing this x minus mu divided by sigma. Don't do like this. Just try to understand what is this mu. Mu is mean of x, right? This sigma square is variance of x, right? In case of this standard normal, see, if you'll follow the proper steps of transformation of random variable, you will get the same answer. Why? Because I will tell you there will be this absolute value of d x divided by dz also, right? That is something you have to do. Those will get cancelled out. Okay, you can try it out and let me know. And so what and for the just to keep in your mind, so what is happening here? So this mu is what is this mu? It's a mean of x. This sigma is standard deviation of x. And this, what is the mean of this z? This is 0. And what is the standard deviation of z? It's the 1. I did the same thing. Z minus 0 divided by 1 whole square, I will get this part. That's all. This sigma is 1, it will be 1. This is one way. Just to keep in mind, right? Quickly. If you want to do all the transformation and also this z, you are getting x minus mu by sigma, and then you have to differentiate this dx divided by dz. So from here it will be x will be mu plus sigma z. So what is the dx divided by dz? So it will be sigma. So here it will be you have to multiply with sigma, right? Let's say this sigma will get cancel out. Something you have to do. Okay, understood? Yes, no?
Yes, sir.
Okay, all right. So let's try to understand some properties. So I will try to give you the idea from the single variable, and then maybe start. So what if suppose just consider this x as a like single random variable with mean mu and variance sigma square. What will be the distribution of y is equal to 3x? It will be normal only. I mean, what will be the mean? Mean will be 3 mu and variance 9 is sigma. I will tell you how. So this, what will be the expectation of y? This would be expectation of 3 times of x. So this will be 3 times expectation of x. So this will be 3 times of mu. What will be the variance of y? So this will be variance of y into x. Variance of 3 into x, correct? So this will be, we know variance of any constant time of x, this would be a square into variance of x. So this would be 9 times of variance of x. So this is 9 times of sigma square.
Yes,
So far
sir.
so good. Now let's try to understand for the vector. So suppose what is the variance of a times of x? So suppose a is a constant vector, and tell me, can you comment on this variance of a x? If you have variance of small a times of x, so this is a square variance of x, right? Can you comment on this? What it should be?
A transpose A variance of X.
Not a transpose, it should be a times variance of x into a transpose.
Yes, yes,
Sir,
yes.
A is
Due to
matrix.
order of multiplicity.
Yeah, it depends on the order of the matrix. Okay, this would be the case actually. Okay, so for example, suppose I have y is equal to
Sir, how,
ax.
Can you explain that, sir?
See,
Variance
this
of
how
is
this
a
is coming?
square. This is a square, right?
Yes,
yeah.
sir.
In vector, how will you get something e square? You are doing a transpose a or a transpose something like that, correct? See, you have to okay, you have to somehow you have to maintain the order of the matrix. Suppose this is 2 cross 2, this is 2 cross 1, then this would be 2 cross 2, this would be 2 cross 1, and this would be
One cross.
what is finally you are getting 2 cross 1. No, something is missing here. This is 2 cross 2, not 2 cross 2. This would be 2,
Sir, 1 cross 2 and 2 cross 2 and 2 cross 1.
2 cross 2 only, right? A transpose again order will be same, correct?
1 cross.
Yes, sir.
No, something I think let me okay, I will take example that in that case it will be clear. Okay, one second, just be with me. So uh, okay, I will take one example that will give you clear idea. First of all, so now this is just for order itself, right? So in okay, are you able to somehow relate this a transpose a transpose something square entries we are getting, right? Okay, so for this a times of x, y is equal to a times x is normal with mean. What will be the mean here? Tell me what will be the mean?
A into mu.
Sorry,
Sir, determinant of A into mean of A.
a is a constant, right? Can you relate with the
A into mu. A into mu.
just relate with a single random variable? What it should be? This is constant times mean vector, right? Yes or no?
Yes, sir.
Right? Constant time mean vector. See, so this would be a into mu. This would be a. It would be sigma a transpose. What is this sigma? Sigma is variance matrix, variance covariance matrix of y. Okay. Okay, see, if you want more explanation for this, let me give you idea. See, for simple case, for scalar, if you have scalar, I mean let's say, suppose this a is just a scalar, a simple scalar, right? Suppose this is a scalar. Okay, then what will the variance of c times of x? I can write c square variance of x, right? That everyone knows, correct? Yes or no?
Yes, sir.
If this x, let's say this x has a, I'm saying this identity covariance, I mean this sigma is identity, for example, covariance is matrix, then what about, you can comment on variance of ax? Tell me.
Sir, could you repeat?
What about the variance of ax if sigma has a identity? What else can I write? Okay, I think
Sir, what is sigma in terms of X?
that is variance matrix, that's all. See, either you can write sigma square for a single variable. I'm writing this big sigma, that's a covariance matrix, variance covariance matrix. Okay, let me derive it. I think everyone is getting confused. So what about variance of AX? How you can write? Usually we are writing expected value of X minus mu. So this would be AX minus A mu, right? Into AX minus A mu transpose. Now can I write this one or not? Yes, no?
So usually variance is variance of x is E of x squared minus
That is single random variable, right?
this.
That is case for single random variables.
Yes, sir.
Okay, this is for, we are dealing with the matrix, right? So to maintain the order, right? So to maintain the order, suppose A is of m cross n, for example, A is m cross n and AX is n cross 1, right? This X is n cross 1, A is m cross 1. Now what it would be?
It will be m cross 1.
Right? This would be, okay, here if you want to do it, this would be m cross n, correct? And this would be n cross m. What will be this variance of X?
N cross n.
Okay, I will come to that point. Anyway, see, for example, tell me this is okay or not? Just to maintain the order, right? So we are writing expectation of X minus mu whole square, right? If I have single random variable, but for matrix notation, can I write X this minus mu into X minus mu transpose? Yes or no? See, transpose of a scalar is same as that scalar only. Just think like that scalar. Okay.
Sir, we can write we can draw an analog in terms of expectation of x square minus expectation of x whole square also. That formula also, sir.
That formula is also work here, but we can deal with we can follow with. We can start with like this also. That's not a problem.
No. In that way, if we write x square will be, sir, what? Expectation of x square in terms of matrices will be?
Again, that will give you some. See, you can write. That's not a problem at all. See, but again, some just to avoid like, see, in that case, you have to do this square. Then you have to do expectation of X whole square, right? In case of matrix notation, it's good to start with like this. Okay. See, if you are okay, tell me one thing. If you are getting confused like this, what will be the AB whole transpose?
Sir, B transpose into A transpose.
B transpose into A transpose, correct?
Yes, sir.
Right. So, and what about if suppose in this case, just treat B as a X minus mu. Let's say this would be whole transpose. This would be, I can write X minus mu transpose and A transpose.
Yes, sir.
Okay. So basically, okay, in short, if you are getting in short, what you can keep in your mind for any random vector, if I want to I want to write the variance formula, right? For any random vector, let's say I want to write y. So this variance of y will be expected value of y minus expectation of y into y minus expectation of y transpose. Okay, this is for any random vector. Okay, just let's start with this. I think we have to discuss some more concepts as well. So for this part, for any random vector y, so now let's say y is equal to a times of x. So I can write y minus expectation of y. So this is ax minus a mu, ax minus a mu transpose, right? I have variance of y as a, or variance of we took y as a times of x. Okay, so this is expectation of ax minus a mu into ax minus a mu transpose. Now from this concept, what else can I write? Tell me what should I write in the next step? This is something I can take A as a common. This would be x minus mu. And here I can take A as a common. It would be x minus mu whole transpose. Correct? So this would be A, expectation of A, x minus mu. And this would be x minus mu transpose, A transpose. Yes or no? And this is something I can write A times expectation of x minus mu transpose, A transpose. And what is this? This is nothing but variance, right? So this would be A sigma A transpose. Okay, this is nothing but variance of AX. So that's what I wrote there. So this is nothing but A sigma A transpose. Correct? Yes or no? Is this clear? How
So
this thing?
the sigma part is what, sir? Actually, x minus
Sigma is okay. Just relate with a single random variable. See, I think this is variance of, suppose I have small a x. X is a single, I mean just universal random variable. How will you write this? A square variance of x.
Yes, sir.
Correct? What is this variance of x? This is sigma. This is variance covariance matrix of x. That's all.
Yes, sir.
Okay.
Okay.
Okay. All right. So is this clear to everybody? So see, just think for single random variable and just extend that part to what to say, that matrix or vector. Okay. See, also you can try this for I mean for this is just to maintain the order, right? What if I have y is equal to a small transpose x, I mean small a transpose x? This is just a vector. What it would be? This will follow normal. What will be the mean? Yeah, tell me what will be the mean?
So A transpose into mean of x.
A transpose mu. And what about variance? Yeah, just think a bit. I'm leaving you. Now I will take one quick example. So let's say I'm saying y is normal with mean mu and sigma. And let's say I'm y taking as a y1, y2, let's say y3. And mu is given to as a 3, 1, 4. And sigma, this variance covariance matrix, is given to as a, let's say 6, 1, minus 2, 1, 13, 4, and minus 2. This would be 4, this and let's say 4. Now tell me, if I will ask what is the expected value of y2, what will be your answer?
One.
1, because this is expectation of y1, expectation of y2, expectation of y3. And if I will ask variance of y2, then
13.
30, right? Because this is y1, this is y2, this is y3. See, all the diagonal elements will represent the variance, and the off diagonal elements will represent the covariance. So this is y2, y2, y2. Very good. What if I will ask distribution of 2y2 plus 3? This would be, I'm writing normal. What will be the mean?
2.
2 plus 3.
5.
5. And what will be the variance?
20. Sorry, 4 into 13.
52.
Everybody is like, is this clear for everybody? This how this 52 came?
Sir, the 52 one, please clear it again.
52 is not clear, right?
Yeah.
So what is the variance of 2y2 plus 3? We know adding a constant or subtracting the constant doesn't affect the variability. That means this is same as variance of 2y2. This will be variance of a times x is same as a square variance of x. This will be 4 times variance of y2.
Variance
And what
of
is the
y.
variance of y2? 13. So 4 into 13, 52. Correct?
Yes, sir.
Let's say I'm defining z equal to c times y, where let's say I'm saying c is nothing but 2, minus 1, and 3. Now tell me, what about expectation of z? This would be expectation of c into y. This would be c mu, right? So what is this c? C is 2, minus 1, 3, mu is 314. Mu is 314. Now this would be what? 6 minus 1,
Plus 12.
5, and 17.
Yes, sir.
What about variance of C times of Z? This is something we took C sigma C transpose, right? A sigma A transpose. So what is C? 2 minus 1, 3. Now what is this sigma? Sigma is this 6, 1 minus 2, 6, 1 minus 2, 1 minus 2, this would be same. Okay, this was 30, 4, 4, 4, 4. So this will 4, 4, 4, and this is 2 minus 1, 3. And this is, what is the order? This is 1 cross 3, this is 3 cross 3, this is 3 cross 1. Now can you tell me, if you are doing C transpose and then C transpose sigma C, will this be correct?
No, sir.
Right, this was 3
Three
cross
cross
1, 3
three.
cross 3, 1 cross 3. Can you multiply in that case?
No, sir.
No.
Now is it clear why we wrote A sigma A transpose?
Yes, sir.
Okay. Okay, so far I know most of the people get bored. Maybe you might be like, what are the things I'm explaining? But anyway, I would like to hear. I mean, is this the rough idea clear regarding this bivariate and some properties and all which we discussed? Yeah.
Yes, sir.
Okay, then can we move to the next concept? Okay.
Sir, could you just show me the slide of that variance CZ?
Variance CZ.
So
okay.
just scroll up a bit.
Yeah, this
Okay,
is the
sir.
okay. Yeah. So the next concept is actually that is that is maximum likelihood estimation. Okay, MLE. So I think most of the can you recall from statistics 2 and tell me what is this MLE, what it does, and what is, how will you find MLE? I mean, if I would ask what is the meaning of likelihood, then what will be your answer?
Multiplication of probability.
Okay, multiplication of probability, that is correct. I'm not denying. What we are getting from there?
So value at which likelihood is maximum or minimum.
Okay, that is whole MLE. Okay, tell me, what do you mean by likelihood? Like what we are trying to do from the likelihood?
So basically, we are trying to find what is the most probable chance to event to be happen.
Okay, basically correct. So what is the likelihood? Likelihood is nothing but it gives you the idea what is the probability of observing my samples. Okay, my samples for a given theta. Okay, what is the probability of that? This is the likelihood. So for example, if I'm saying x1, x2, and so on, this xn, this all are IID x. Okay, and let's say with the parameters for each, let's say theta 1, theta 2, and so on. So if you see from here, this all fx, right? This depends on the theta, right? Fx of x, right? This PDF will depends on theta, right? Parameters. So actually this likelihood of observing your sample for a theta, this is nothing but what is that, this fx of x, fx1 of x1 into fx2 of x2, and so on. I mean, till let's say you have n. So basically if till n, so basically what we are doing, we are, it's a product of all PDFs. So this fx of each exercise for your theta 1, theta 2, and so on, theta n. So what is the next job in maximum likelihood estimation? So we have to maximize the likelihood. So it's the same approach. I mean, Sometimes in likelihood you will get some complicated function, right? But in that case, taking, so how will you maximize a function?
So derivate and put it to 0, but here we
Derivate
will
and
use
put,
log.
correct. So but in sometimes you will get some complicated function, right? Some e response something. So in those scenarios, actually differentiating is little bit difficult. That's why we are taking log, because maximizing a likelihood function is same as maximizing the log of that function. So what we used to do, we'll take the log of this function, and then what is the next job? It will be, we have to differentiate this with respect to that parameter and equate with 0, and then you can find out the maximum of that function. Is this clear? Yes? No?
Yes, sir.
Okay, let me start with some example. So example is, actually we have to discuss too many things, MLE, and then okay, anyway, let's try to finish. It would be okay if it is going beyond 10.
Yes, sir.
Okay, this is Bernoulli P. Suppose I'm saying I have x1, x2, and so on xn. This all are follows IID with Bernoulli P, and I want to find the MLE of for this Bernoulli P. Suppose I have samples. Okay, I have one samples, and which samples are x1 small x x2 small xn, right? These are the random variable. I took one sampling instance. What is this? Is each xi will represent, each xi will take either value 1 or 0, right? This will be this with success probability p, and 0 with failure probability 1 minus p. Correct? So far so good?
Yes, sir.
Suppose this is the sample you have observed. So let's say you observed like this 1 0 1 1 something, right? Some 0, right? This is n observations you have. So suppose I'm saying let small w, I'm just doing in general, right? You can do it for, you can take some 10 sample, 20 sample, something like that. Let w denote the number of this ones in the sample. Okay, I mean, let's say you toss a coin 10 times, right? Or let's say 5 times. Then what is this w? W is 3. This 3 times 1 we getting. Okay. So if w times 1, I mean, you are getting, okay, then what will be the likelihood? First of all, this likelihood of observing this sample. Suppose this one you got first time, then what will be the probability? This p. Then suppose w times you got, let's say, then w times there will be p. Yes or no? Right? And remaining you are getting 0, right? So that means 1 minus p into 1 minus p into and so on 1 minus p. How many times this would be?
W minus 1.
N
That's a
minus
loop.
W time.
Sorry, N
correct? Is the idea clear? So now what is happening here? So this is p raised power w 1 minus p raised power n minus w. You can think with very simple example. I took 1 0 1 1 0. So this would be p raised power q 1 minus p square, right? Now this is likelihood. I will take log of this. So what is the log? It would be log of
So it
p
will
raised
W
power
log.
w into 1 minus p raised power n minus w, and this would be log of p raised power w plus log of 1 minus p raised power n minus w, and this would be w log p plus n minus w
Log
log
1.
1 minus p. This is log of n. Now what is the next job? I have to differentiate this with respect to p. Correct? Yes or no? So this would be w by p plus n minus w divided by 1 minus p, and this would be minus 1, and I have to equate this to 0. This would be w by p minus n minus w divided by 1 minus p equal to 0. So from here what it would be? I will get w by p equal to n minus w divided by 1 minus p. So basically what is this? This would be w into 1 minus p equal to n minus w into p. Okay, everyone is following me, or I'm doing bit too much fast?
Yes, sir.
No,
W
it's
minus
okay.
WP equal to NP minus WP. So what is from here? From where you will get W is equal to NP. So basically this P star or P hat ML, you can say this is nothing but W by N. Okay. So this is what? This W by N is what? This is nothing but sample mean itself. Would you agree with me if I'm saying P at ML is x1 plus x2 plus so on xn divided by n? Yes or no?
Not aware, sir.
Okay, I will tell you. Suppose I toss the coin 5 times, right? Then this will be W by n. So this W by n, how many times 1 is there? 3 by 5.
Yeah.
Correct? Now, if you take the average of this sample average, 1 plus 0 plus 1 plus 1 plus 0 divided by 5, this is again 3 by 5. That's all I'm saying. This W by N same as sample mean. In case of Bernoulli. Is this clear?
Yes, sir.
Okay. So, the same thing, you can try similar way in this. Okay, should I do for exponential or should I do different example? Is it? Yeah, tell me.
So this is for only Bernoulli, sir. So it means for every other type of like binomial or any other
Yeah,
geometric.
you have to proceed like this. Okay, let me do for exponential and I will take one more example, then I will proceed. So x1, x2 and so on xn. This is IID x, suppose I'm saying. And x is nothing but exponential with parameter lambda. Okay. Now what will the likelihood of this? Likelihood of L x1, x2, xn. This will be fx1 of x1 into fx2 of x2 and so on fxn of xn. Correct? Product of all this, right? What will the PDF here? Lambda into e raised power minus lambda x1 into lambda e raised power minus lambda x2, so on lambda into e raised power minus lambda xn. Correct?
Yes.
This will be lambda raised power n and e raised power minus lambda x1 minus lambda x2 power will get added. Yes or no? Correct? Yeah. This will be lambda raised power n and it will be lambda e raised power minus lambda. It would be x1 plus x2 plus so on xn. Is this clear?
Yes, sir.
This would be lambda raised power n e raised power minus lambda. This is what? Summation of xi, correct? But this is likelihood. What will be the log likelihood? It would be log of lambda raised power n plus log of e raised power minus lambda summation xi. Now tell me, what should I write? It would be n log lambda minus lambda times summation of xi. Correct?
Yes, sir.
Now this would be what? I mean, we have to differentiate this with respect to lambda. This would be n by lambda minus summation of xi and I to equate with 0. So from here, what else I will get? N by lambda equal to summation of xi, and what is the lambda hat? It is nothing but
n by summation of x.
n by summation of xi. See, one thing you can keep in your mind, one small trick. What is the like in case of exponential distribution, I want the MLE of lambda. In case of exponential distribution, what is the mean? Mean is 1 by lambda, correct? Correct?
Yes, sir.
What is the lambda? 1 upon mean.
Yes.
And what is the lambda hat ML here? 1 upon mean or not? Mean is summation xi divided by n.
Okay.
Yeah. Yes.
Are you
Yes.
getting? Yeah.
Yes.
Let me take one different example and then I will jump to the next topic. What is that example? Let me take, let's say x is distributed at 0, 1, 2, 3, because this kind of problems you may get, I mean, it should be clear in your mind. This is different. It's not any very standard PMF or PDF we are dealing, right? So suppose for this PMF is given to us and we have given samples, right? I mean, some observed samples, some 10 samples. So like this, let's say 3, 0, 1, 2, 3, 2, 1, 0, 2, 1, 10, right? 3, 3, 6, 10. Okay. So what will be the likelihood? Likelihood will be product of I is equal to 1 to 10, right? All this PXIs, right? All these probabilities, yes or no? So what you have to observe? So you can see how many times 3 is occurring in the samples. Basically, this is small x1, small x2, small x3, small x4, and so on, small x10. How many times 3 is occurring?
Twice.
2 times.
That means it would be
1
1
minus
minus
2
theta divided by 3 whole square, right? How many times 0 is occurring?
2 times.
2 times. So this would be 2
4.
by theta,
The
2 by
whole square.
3, 2 theta into divided by 3 whole square, and then
1
1
is 3
3
times.
times. So that would be theta by 3,
Whole cube.
sorry, whole cube, correct? And what about this? 2, 1 minus theta divided by 3 whole
Cube.
cube. Now this is likelihood, right? So you can extract all the, so how you just extract the constant. So this would be 2 raised power 5 divided by 3 raised power 10. I can take outside or not? Then this would be 1 minus theta raised power 5 and theta raised power 5. Everyone is getting this part? This step is clear to everybody?
Sir.
Yes, sir.
Yeah?
Yes.
Okay. So this is likelihood. What about log likelihood? I mean, this would be log of this constant plus log of 1 minus theta raised power 5 plus log of theta raised power 5. Yes or no? So this will be log of constant plus 5 log 1 minus theta plus 5 log theta. Correct?
Yes, sir.
So similarly, if you see this, what we have to do, we have to differentiate this del with respect to theta. So this constant will be 0 plus this will be 5 divided by 1 minus theta and plus 5 by theta. Am I right?
Sir, into minus 1.
Minus
Into
1.
minus 1.
Yeah. So this would be basically from here, it would be 5 theta equal to 5 divided by 1 minus theta, and I think this is 5 minus 5 theta equal to 5 theta. So 5 minus 5 theta equal to 5 theta. So that will be 5
Equal to half.
equal to 5 theta basically. Yeah. So theta hat will be, theta at ml will be 5 by 10, which is half. Okay. Is the idea clear?
Yes, sir.
Yes, sir.
Okay. Now, so let's start this something called the Gaussian mixture model. Any one of you can give me idea about Gaussian mixture model? If you know something or you want to say something.
Sir, when the curve of normal, like L-shaped curve, has more than one mean, like 2 or 3 means, then we use Gaussian mixture model to identify which mean correspond to which curve and which cluster.
Correct.
So two normal distribution are mixed.
Okay, correct. Anybody else? Yeah, that's correct. Anybody else? See, whatever suppose somebody came to you and they said one word to you or one line. What should be your guess? That's all I wanted to hear. That's all. I'm not saying this is any exam you have to give correct answers only. That is fine. Guess is also fine. At least you are thinking something. Okay, so see, silence always, I assume you are getting everything. So please acknowledge the things, okay? Anyway, if you want to just quickly finish the things, I can finish. That's not a problem. I'm just spending this much time so that you can participate and share your thoughts like this. If everything is for me, I will come and I will quickly finish it up and I will end the session. Okay, then there is no need to cross. Okay, sorry for my harsh word, but anyway, okay. So let me start. So see, in this MLE, right? So we were we what we did, we estimated our parameters. We find out the maximum likelihood estimation of parameters. So what we do, suppose we have some little bit complicated data. I mean, suppose I have a real line and I have data like this, right? Some data like this, some data like this, okay, some data like this, some data is like this, okay. Now my goal is we have to come up with some model which explain this data, okay. we have to come up with some model which explain this data. Okay. So since this is on real line, etc., I think this is not 0, 1 and all. So I don't, so we can say for this Bernoulli or binomial is not going to be good thing. So another thing you can think of, let's say these are the real numbers, I could guess as it as a normal distribution, correct? See, whether that guess is good or bad, that come later, but no one is stopping us to approximate that part with the normal, yes or no?
Yes, sir.
Correct. So for this scenario, suppose I'm saying, and we estimated the mu of this data set, and suppose somewhat this mu hat ml by the maximum likelihood estimation, mu hat ml is coming around this, and the graph of this will be like this, correct?
Yes,
Okay.
sir.
But my question is, okay, this is a normal with the mean mu hat ml and some, let's say, sigma square is known to us. So can you tell me, is this good approximation for this kind of data set?
No.
But this is just for the central data, not for the left or right data.
Right. What is the reason? So for, if you see for this cluster, right, this left side cluster and this right side cluster, there is very low density for these data points, correct? Are you getting my
Yes.
point? Right. So what is happening here? So this model, this normal, this Gaussian model, in this case, is not good for this kind of data set. Correct. What we need something else, right? We have to come up with some alternative approach for this. So if you see, there are some 3 different cluster and all. So what I can do, I want density. Okay, let me draw that density first of all. So if I'm drawing this part, okay, suppose this is cluster 1, this is cluster 2, this is cluster 3, okay. Correct. This is now, this seems a good model, something, right? For to if I want to generate the data, in this case, if you want to, let's say I said I approximated the model for this, right, as a normal mu hat ml and sigma square. See, if I want to generate the now once this model is fixed, if I want to generate the data from this, so most of the time it will give me data from here, right, with this region, correct? Not for these two age, right, correct, these two clusters. So in this case, what is happening, right? So there is not a single Gaussian, right? This is this is one Gaussian with some another mu. This is another mu and sigma square. This is another mu mean and sigma square. Are you getting my point?
Yes, sir.
So what is
Yes,
this?
sir.
This is nothing but, this is kind of, we want a density like above to explain our data set, right? So this is something clustering behavior, right? For this cluster, I have one another distribution. For this cluster, I have another. For this cluster, I have another distribution. Okay. So this is not a single Gaussian. This is a mixture of Gaussian. Okay. Now let me take one example for this. So for example, suppose there is a class, right? In that class, and you want to think for marks in an exam. Okay. So some students, suppose they didn't like prepare for the exam very well, and for them you can define as a let me draw the graph, some different graph again. This is part, this is another, and this is another. Suppose for this, they are the students who didn't prepare very well, right? And these are the students who kind of, prepare very, they did preparation in moderate way. And this last one, suppose they prepared very well, okay. Is this okay? And suppose they who didn't prepare for this, let's say this is normal with mean -4 and variance 0.5. Suppose the exam hai like it, this is negative marking exam, and this would be, let's say, normal with mean 0 and variance 1, and for this, let's say this is normal 5,1. Okay, so far so good. There are 3 types of students, right? So this and okay, if you are modeling this with a single Gaussian, will that work?
No.
No, right? Not at all. So, but there is not okay, there is another factor. What is that?
Standard deviation.
No. See, there will be some proportion of students, right? So that is called pi 1. There is another one type of cluster, right? So there is, let's say you are saying, I'm saying 40% students are of type 1. Okay, and let's say 30% students are of type 2, and this 30% students are of type 3. Is this okay now?
Yes, sir.
Okay, see what is happening here. So this is not a single Gaussian, this is a mixture of Gaussian, right? So you have 3 different kind of scenario, right? Another example you can take, suppose you are interested to you want to observe the, let's say, height of students in a college, right? Then if all the students belong to a single group, right? So then in that case, height might look like a bell-shaped curve. In that case, it will be Gaussian, right? Single Gaussian. But in reality, this case is not going to happen, right? This data may come from multiple groups, right? Let's say there are you can think of 2 groups, for male students and female students, yes or no? And for male, the group of male students, there will be like different average and spread, I mean mean and variance. And for group 2, which is of female students, there will be different mean and variance, yes or no? In that case, you can't model overall data in a single Gaussian, but with a mixture of Gaussian. Correct? So
Yes, sir.
in this case, what is happening actually? So there are 2 steps, right? So what are those 2 steps? So first step is, we don't know, right? So suppose you want to generate the data, we don't know from where it is generating, right? So what you need, first of all, you need to know from which cluster or from which mixer that data is coming from. Are you getting my point? Right? We have to pick from which mixture, or you can say the cluster, a data point comes from. Okay, let's say I'm saying that is for that probability spy k, right? Are you getting? So suppose there is new student came, and you have the marks of that student, right? Then how do you know, right? Or let's say you want to comment on the predict the marks of that student, then you should know from which mixer or from which cluster that student is coming.
Yes, sir.
Right or not? If you know the, let's say, see, if you know the marks of that student, let's say marks of that student is out of 10, let's say that marks of a student is 4, you can comment that student might come, there is a 30% chance that student is from cluster 3, correct? If the marks is let's say for that student is 0 or close to 1, you can comment there is 30% chance that student is from cluster 2. And if marks is in negative, you can comment there is a 40% chance that the student is from cluster 3, correct?
Yes, sir.
And see, if suppose there is a new data point, let's say here, right? So what can you say about this point? You can say there is a 40% chance this has been generated from this normal distribution, right? And there is very less density also, there is 30% chance this blue point can come from this green one, yes or no? And there is 30% chance this will be very less density for the third cluster actually. Okay, Is the rough idea clear? So what we have to do, actually what we are doing, we have to pick the mixture, which mixture a data point come from. Once you get the information about cluster or mixture, then what will be the next step? I will generate the data. I will generate this data point from that mixture or cluster. Okay, is the idea clear?
Yes.
Okay. Now, so what is happening in step 1? Let me rewrite again. So what is we are doing? We have to, let's say, generate a mixture component. So this I took in the graph for 3. Let's say I have some k mixture. Okay, so what is that? Let's say 1, 2, and so on k. Okay, and this is k, and I'm saying this zi, there is one zi I'm defining which belongs to this 1, 2, and so on k. Okay, so what does this mean? So if I'm saying zi is equal to 2, okay, if zi is equal to 2, then this means the ith data point is coming from cluster 2 or mixture 2. So once you have this information, this ith data point is coming from cluster 2, then I can easily generate the data point with mean 0 and variance 1. Correct? So what is happening here? So this probability zi is equal to, let's say, L is equal to pi L, right? Ith data points, what is the probability that ith data point is coming from cluster L, or this is pi L, and this is all probability. So this probability of all pi I will be equal to 1. Summation of all probability, summation of all pi I will be equal to 1. Correct? So once you have information about this step 1, what is this step 2? So this is, once I have information, I will generate xi from this normal with mean mu zi, right? So this zi means from which cluster it is coming from, and then sigma zi square. Is this clear? This means this ith value from Lth cluster. Okay, is the rough idea clear about this mixer model?
Yes, sir.
So there is something called observed data and unobserved data. So see, what you are observing, right? I have x1, x2, xn, right? Correct? This is observed one. And what is unobserved? There is something hidden, that is this z1, z2, zn, right? We don't know from which cluster this data is coming from, right? This is unobserved actually, or sometimes we use the latent. See, this Gaussian mixture model, and after this we'll see EM algorithm, etc. So these are just to give you intro or high level idea about these two topics. Once you'll move in MLT course, or those who are doing MLT simultaneously with this MLF course, you will learn in detail, right, about these two topics. But anyway, so we'll try to understand. I will try to give you some rough idea about this. So is the rough idea clear about this GMM, right? Gaussian mixture model?
Yes, sir.
Okay. So the next thing is, it's called maximum likelihood of GMM. Okay. Maximum likelihood of Gaussian mixture model. See, first of all, we need to think of in maximum likelihood, what we are doing, we are estimating the parameters. Let's try to understand how many parameters we have. First of all, how many parameters do we have here?
3.
Not 3. So let's say this pi. This pi is how many pi's?
3.
Pi k, right? For
Pi.
k cluster, right? Yes or no?
Yes, sir.
And for all k. And for all k, we have two another, mu k and sigma k square.
Yes.
Correct? So what are the total parameters? Total parameters how many? For each k we have 2, right? So for 2 cluster it would be 4, for 3 it would be 6. Similarly for k cluster it would be 2k.
Yes, sir.
Correct? Plus how many pi's we have? K pi's, right? So it would be plus k. right? So do we, okay, is it right if I'm writing k only? This would be k or k minus 1. I'm right. So I'm giving you the correct answer. It should be k minus 1. You have to tell me the reason why.
Sum of all the k.
Correct. So there is one constant. So this summation of all pi I is equal to 1, right? If you have information about k minus 1 pi, I can evaluate the kth one, right? So total parameters we need to estimate, that is 3k minus 1. Okay. Now, what is the next job? So next job is, what is the likelihood of this all stuff? So likelihood of mu1 up to mu k, sigma 1 square and so on, sigma k square and pi 1 and so on, pi k, and this is x1 up to xn. This is likelihood. So what is this likelihood? So first of all, I have to find out the product of all this density of mixture distribution xi and all the parameters, right? Mu1 up to mu k, sigma 1 square up to sigma k square, and pi 1 up to pi k. So these are just a notation. But tell me one thing, how will you find this density of mixture distributions? There is something. First of all, it should be, what if I'm writing summation of k is equal to 1 to k pi k into density of xi mu k comma sigma k square, yes or no, for this density, right? Overall this mixture density for this mixture is nothing but pi k, weightage into this density plus this weightage into this density plus this weightage into this density. Is it okay? Correct? Right? So this is likelihood. Now, what will be the next step? So this will be I is equal to 1 to n. This is summation small k is equal to 1 to k. This is for cluster, right? So this will be pi k into, what is the density of this normal? What should I write here? Yes, tell me.
1 by root 2 by sigma k.
Okay. Basically, it's e raised power minus xi minus mu k whole square divided by 2 sigma k square divided by square root of 2 pi sigma k.
Yes.
Correct? Now, what is the next job in case of likelihood? We have to take the log of this likelihood, right? So this would be what? Tell me. This would be summation of I is equal to 1 to n log of summation small k is equal to 1 to k pi k into e raised power minus xi minus mu k square divided by 2 sigma k square divided by square root of 2 pi sigma k. Correct? Now tell me, if in case of normal distribution, right, if you I didn't solve the question for that, if you find out the MLE of mu and similarly for sigma square, then it's very easy, right? What you have to do, you have to take the log and you have to differentiate with respect to mu, and similarly what we did for Bernoulli and exponential, right? We have to differentiate with respect to that parameter equate to 0, we'll get MLE for that. But in this case, actually, what is the problem, right? The problem is to deal with this summation side, right? If you have log of e raised power minus something, you will get one simple equation, but in this case it's not possible. So actually this is in this case actually this is not possible to solve this analytically. Okay, so what I mean by analytically, you won't get any good you can say good expression for this mu hat ml. Usually we are getting mu hat ml, right? So in case of normal, you can see mu hat ml, we are getting summation of xi divided by and something like that, right? So this is the meaning, we won't get this. We can't solve this analytically. If you cannot solve this analytically, then then we need to come up with some alternate approach. Yes?
Yes, sir.
Right?
Yes, sir.
Okay, this is the different thing. Okay, I will come to this part. So we have to come up with some alternate approach. So what is that alternate approach? That is called EM algorithm. What is the full form of this EM algorithm? Anyone? Okay, let me tell you. This is
Expectation mean, I mean, mix.
maximization algorithm. Okay. See what is happening. See, you have data comes from multiple groups, right? I mean, your data comes from multiple groups, but we don't know which point belongs to which group. Okay, as we saw the example of that top performance and who prepared in moderate level and who didn't prepare at all. So we saw, so in the group of students, right? So some are top performance, some are average, some are very weak, right? So what is the things we have? We observe only the score, right? We are not observing the group levels, correct? So what is happening here? So if you see in this case, where it went, yeah. So suppose this is one example. Suppose this red is one group students who didn't prepare very well, right? Very weak, and the green one is who prepared in moderate level, and this I mean some are average, and this blue one is top performer. If you have information about these clusters, right? This, I mean, if you know the type of student, then you can easily estimate the parameter, right? If you know the information about this is coming from this red group, then you will have information about distribution and you can easily estimate that parameter. Yes or no?
Yes, sir.
Right? If you know that student is coming from green, blue, accordingly you can estimate the parameter, correct? But in reality, that is not going to happen. You will have only scores, correct? Right? You don't know which data point belongs to which group. Basically, you cannot directly estimate the parameters.
Yes, sir.
Right? If we cannot estimate the parameters directly, then what is the next approach? What else we can do? So the key thing about EM algorithm is you can think like this. So one if you say in one line, so that is you can think of EM algorithm as first we have to guess something, right? From that guess we will improve, and then we will repeat this whole process. Okay, are you getting? Is this clear? So what is going to happen? So if you have seen the lectures and this chicken egg problem, or else forget about chicken egg problem. If you see this, if you have data like this green data, suppose you started with your, so your initial guess is this blue circle and red circle. Okay, is this okay? Are you getting my point?
Yes.
Let me write one line, maybe that will help you. So suppose I'm saying we don't know, right, the data coming, like from which cluster the data comes from. Okay, so first of all, what are the things we know to know which Gaussian or mixture, okay, a data point belongs to. Okay, if you want to know this, what else the things you need?
Pi value of,
Not pi, we need mu k, sigma k. What I'm trying to say, if you want to know the which mixer a data point comes from or belongs to, you should have information about mu k or sigma k, right? Or to know or to estimate this mu k, sigma k, what else you need? You should have information about cluster assignment, correct? Are you getting? But in reality, we don't have either, right? right? Neither this nor this, correct? What else you have? The only thing you have this data set.
Point, yeah.
Are you getting my point? Right? So you to know the mixture, you need mu k or sigma k. To know and to estimate mu k and sigma k, you need the cluster assignment. So what I'm trying to say, once you know, suppose you get to know the one data point is coming from this cluster, you can easily estimate this mu k and sigma k.
Yes, sir.
Or else suppose you know information about this mu k and sigma k, and then you can comment on cluster, right? You can easily tell this data point is coming from this cluster, yes or no? Or there is some 90% chance or 40% chance that data point is coming from third cluster or cluster second or first cluster, something like that. Okay. Okay, fine, all right.
Yes,
So
sir.
what is happening here? We don't have either. So what we will do? So let's consider that chicken egg problem. I mean, you don't have chicken, you don't have egg, right? How will you solve this problem? Just consider a random chicken, and then from that random chicken you can have an egg, and then from egg to chicken, and etc. Something like that. So we have to you have to do this iterative process. So you can relate this as a, let's say I'm saying this chicken as a, this is our parameters. Okay, and this egg you can consider as a latent assignments. Okay, and in both cases neither exists first, right? If that is the case, how will you do? So what should be your steps? So my steps will be, I have some imaginary chicken. Okay, so what I mean by imaginary chicken, so mathematically you can think you are going to start with some initial guess. Okay, initial guess means, let's say I'm saying theta naught is, my parameters are, let's say I'm saying mu k naught and sigma k naught and pi k naught. Once you have these parameters, correct? Are you getting my points? Once you have these parameters, so using this theta naught, using your initial guess, what else I can do? I will compute the probability of what? Suppose I'm saying, given that this nth data point, I'm saying what is the probability that this will belongs to, let's say, cluster K. I can compute this or not. If I have information, let's say I started with initial guess of my parameters, then I can compute the probability of whether that data point or another data point will belongs to cluster K. Yes or no? I can do this.
Yes, sir.
And usually we denote, okay, for example, how can you compute this? This is something you have to apply the Bayes rule. So for this I can do probability x equal to xn, given that z equal to k into probability z equal to k, and what about denominator? Denominator will be probability of x equal to x. Is this clear to everybody? Now, what is the numerator part? I can rewrite. So x equal to xn, given that z equal to k into probability of z equal to k. What else can you comment on this denominator part? Can I write this is a summation of j is equal to 1 to k, probability of x equal to xn, given that z equal to, let's say, small j, into probability that z equal to j, yes or no? So this is what is the probability of nth data point. So it's a probability of first cluster into, given that it is in first cluster, what is the probability for that, correct? It is something like that. You can think like this here. So let's say this graph, suppose I'm saying I have this blue data point, right? How I can compute this probability of this point? It would be 0.4 into this probability plus 0.3 into this probability plus 0.3 into this probability, correct? Now what is the next job? So this is something, this, what is the probability of z equal to k? For cluster K, it is pi k into, this is normal, and this will be normal, right? We are taking, so this is xn, given that for what are the parameters mu k and sigma k, divided by denominator will be summation j is equal to 1 to k, this is pi j, and the normal xn, given that mu j comma sigma j. So So this usual notation is gamma, Z, and K. Okay. Okay, so this is something actually, this gamma, Z, and K is nothing but the same probability. This is what is the probability that this nth data point will belongs to cluster K. So this is what is we are doing. This is something we are finding the cluster responsibilities. Okay, this is one technical word. If you are getting confused with this, some difficult equation notations, no need to worry about this. There won't be any questions, but it's important to understand because you'll get, I mean, anyway, so you will learn this topic in detail in MLT course. But as of now, we have to just get some high level idea about this. So this is something called E step, right? So, and what is the second step, which is called M step? And what is this M step? Is the E step is clear to everybody? First step. Okay. So once you calculated this cluster responsibilities, right? So what we will do? We are going to re-estimate the parameters using the current responsibilities. Okay, responsibilities. Is this clear? So basically, once you see from here, once you get the cluster responsibility, right, information about cluster, we are going to re-estimate the parameters, right? So if you see in the first step, what we did, we started with initial guess. We get some information about cluster, and then I will re-estimate the parameters. So what will be the formula actually? Mu k nu. So nu means after initial guess, so it would be 1 upon n k. This is cluster. Summation is small, I mean, it would be small n is equal to capital N. I'm just writing the formula directly, no need to worry about. So this would be Z n k, gamma Z n k into xn. Okay, and this sigma k nu, I mean, for this variance, it would be 1 upon n k. It would be summation n is equal to small n is equal to capital N. This is gamma Z n k, and this is x n minus mu k nu, and it would be x n minus mu k nu transpose, right? So if you see, if you have one single univariate normal random variable, then in that case, sigma square ml would be 1 upon n. This would be summation xi minus mu hat ml whole square. So to maintain the order, in this matrix multiplication, it would be this into this transpose. And once you re-estimate the mu and sigma, what will be the re-estimate of pi? So it would be nk divided by n. So these are just formula. I won't say you have to memorize everything. No need to, but just it should be clear in your mind. I mean, at least steps and all. So now tell me, is the rough idea and steps are clear? Okay, this would be Z and K. So from this graph, actually, if you see from this diagram, so you had this data, you started with initial guess, this blue and red circle. Accordingly, you re-estimated your parameters, and then again in the next iteration, you did once you find out the cluster, you re-estimated the parameters. Then you find out the cluster, you re-estimated the parameters, and finally you will end up to converge this like this. Okay, so it's an iterative process. You have to repeat the process. Okay, is the rough idea clear till now? Okay, regarding this algorithm. Yeah. Okay. Well, so let's discuss a few more topics. Those are Markov's inequality, and Chebyshev inequality, and the we'll see something called Hofting's inequality, and weak law of large number, and central limit theorem. So we'll go through these topics quickly. Okay. Now, any one of you can comment when this Markov inequality comes into the picture. Yes.
Sir, when questions like at least, at most are asked,
Okay, so that is something we are getting from inequalities, right? We are getting upper bound in Chebyshev inequality. You will get some lower bound and upper bound and all. My question is, when we are using, like, what is the need of this Markov inequality? Okay, I will start with some example. Maybe after that you can give me idea. Suppose I am saying x follows binomial, or let's say 2 comma 1 by 2, for example. And I would say, what will be the suppose I'm asking what is the probability x greater or equal to 1? How will you compute? You will say probability x equal to 1 plus probability x equal to 2, correct? And you will compute, right? So this will be 2c1 half raised power 2 plus 2c2 half raised power 2, and some value I will get, right? Let's say I'm getting value a, some exact value, correct?
Yes, sir.
Right? But so this was, in this case, I'm able to compute this exact probability. So what Markov inequality says actually, so let me write. Suppose x is a positive random variable, usually you can say non-negative random variable, with, I'm saying, expectation of x with mean mu, then probability x is greater or equal to t is less or equal to mu by t. So my where mu is expected value of x. My question is, if you see this from the binomial, if I'm able to calculate the exact probability, then what is the need of calculating this upper bound? Say this upper bound I can say 1, right? And anyway this probability is not going to exceed 1. But my main question is, what is the need of this bound then?
Sir, if the binomial is suppose 2000 comma 1 by 2.
Nowadays you have computers, you have Colab, Python, R, etc., Excel, Google Sheet. You can calculate within a minute.
Suppose distribution
Is not
equals
known to us.
not known. Yeah.
Yeah. So that in those scenarios, this Markov inequality helps is coming to the picture. So for example, say in this case, I can easily calculate this exact probability. There is no need to compute the this bound, right? Even if you, by using this information, can you tell me what will be this upper bound? Probability x greater or equal to 1. This would be less or equal to mu. What is the mu in case of this binomial? N into p. That is 2 into 1 by 2. That is 1, right? It is 1 by 1. Anyway, I'm getting probability x greater or equal to 1 is less or equal to 1. Yes or no? Correct? So what you can comment, so this probability cannot exceed 1. Okay, that is one way to look at it. Another way, so in real life, suppose I'm saying I have a scenario, and I'm saying suppose x represents the number of products, produced in a factory, okay, in a week, or let's say per week, okay, with mean 50.
Excuse me, sir. Live stream had been stopped, sir.
Okay. One second, let me restart. One second, let me check this. Okay, so there is some problem with streaming. Okay, maybe we can continue in the next session. Will that be fine? Okay.
Yes, sir.
So this Saturday you guys have OPP, right?
Yes, sir.
Okay, then what about Monday? Monday will work, or should we discuss during the revision session?
So Monday is fine, sir.
Monday is fine, right?
Yes, sir.
Okay, then we'll continue from this inequality, yeah, in Monday session. Okay.
Okay, sir.
Okay, sir.
Okay. All right. Okay. Yeah. Any doubt?
No, sir.
Okay. Okay then. Thanks all. Bye bye.